Hey friends, welcome back. So now we will see the exploratory data analysis or EDA in our AI/ML journey, which also plays very important role because it has its a significant concept, right? So which we need to know whenever we use all our machine learning or deep learning concept in terms of AI. So let's get start. What basically EDA is as exploratory data analysis, which basically is a procedure for analyzing data, techniques for interpreting the result of all those procedures, right? Or we can say it is a way of planning the gathered planning the gathering of data to make its analysis easier, right, more precise or more accurate, and all the machinery and result of mathematical statistics which apply to analyzing data. Now we have been talking about data. So what basically data is, as we can understand it by some raw facts, right? So that could be our data, which could be anything, like in terms of machine learning, the data refers to data that we use to train and test or validate our model, right, when we talk about machine learning. So a very common kind of data we deal with us is structured data, right? So the data could be in a tabular format, then only we can work on that. So it is no different from the regular Excel spreadsheet we often encounter, right? So here you can see a simple example of data we have in structured, or we can say in tabular format. So from this data we can validate, or we can test, or we can train our model, right? So beside the regular tabular data, we also encountered unstructured data that could be text, images, audio, videos. All these are just kind of data. So despite the kind of data, we always convert them into arrays of number for our model. Now, if we talk on the example of data types, so of course, in the Python, we have actually very rich set of data types. We can say the list, dictionary, string, int, tuple, set, and many more, right? Variable, yeah. So mainly there are two types of variable whenever we talk about variables. One is qualitative and another one is quantitative. So what happens with the qualitative data? So that is basically a numerical value, we can say. So let's see, this is a broad category for any variable that can't be counted, right? So that has no numerical values. Okay, so that means there is no numerical values, and also nominal and ordinal variables fall under these categories, right, with the qualitative variables. But when we talk about quantitative, so again, by the name itself, here you can see the quality, right? So the quality cannot be counted, but the quantity can be counted. So here it is quantitative, a broad category for any variable that can be counted or has a numerical value associated with it. Example of variables that fall into category include discrete and ratio variables, right, which can be counted easily. So this is the main difference between both, right? So as we progress in our AI/ML journey, we will refer qualitative variables as categorical variables, right, and quantitative variables as continuous variables. All right. So any attributes whose value cannot be used for arithmetic operation, we get its data type, or we can say data type as a categorical values, wherever for those attribute whose value can be used for arithmetic operations, we use its data type as a continuous data type. Second thing is we have very common term, that is descriptive data measures. So basically most of the time you might heard about a measure of central tendency, right? Whenever we talk about mode, median, and mean, so we have three measures of tendency, we can say. So what happens when we measure things of some kind, fairly large number of such measurement will tend to cluster around the middle values, right? And such a value called a measure of tendencies, all right, or measure of location or statistical average. So let's see, first thing we have is mean. Again, as this is nothing but basic mathematical terms but very important, right? So the general mathematical average is nothing but mean. When we get the sum of observations divided by number of observations, right? So arithmetic mean is very susceptible to extreme value or fluctuations in data, right? So that is not the right measures to consider when the data contain a lot of extreme values. Okay, now second thing is median. So the central value in an order set by position. So what we do is, to get median, we get the number of observation plus 1 divided by 2. So that is that value in an ordered set. So the set is ordered. So how we get that? We first sort our values, whatever the values that are, and then we get the median value. So to count the number of values plus 1 divided by 2, so that will definitely return the median. And median is such that 50% of the observation that is correct are above the median and 50% of the observation are below the median. So we are nothing but getting the mid value. Okay, but it has better resistance to outlier compared to mean. All right, when we talk about mode is nothing but the value that which occurs most often, right? In other word, mode has the maximum frequency of occurrence, right? So if we again sort our list and count the occurrence, most occurrence value, so that is nothing but our mode value, which is highly resistant to outliers. So what the outliers, again, as we have already discussed them, but definitely we will see them with some example. Next thing we have is measure of dispersion. So what basically happens in central tendency that describe the central point in a data set, whereas dispersion, or also known as variability, that describe the spread of data, right? How the data is spread. So that is nothing but dispersion, right? So if we talk about example of measure of dispersion, that include standard deviation, range, kurtosis and skewness, right? So if we talk about variance or standard deviation and the relation between two, so what basically happened, we have the following formula, that is, right, you can check this out. So the average of the square difference from the mean is nothing but our variance, right? Remember that the average of the square difference from the particular mean is nothing but our variance, where standard deviation is quantitatively expressing by how much each data point differs from the average mean, right? And standard deviation is obtained by calculating the square root of variance, whereas standard deviation representing by the sigma. All right, next thing we have is range. So range is nothing but this is the difference between the highest and lowest value of a set. So that is nothing but whenever we talk about the highest and lowest value and the difference between them, that is our range, like from here to there. And the other thing we have is the quartile. So quartiles are nothing but these are the split split the values into 4 equal parts, right? The first quartile that divides the smallest 25% of the values from the rest, that other part. Second quartile, which divides which indeed is the median, that divide 50 percentile of the 50th percentile of the values from the rest, that larger or equal to median. And third quartile divides the smallest 75th percentile of the values from the rest that are large, right? So this is nothing but q1, q2, q3, first quartile, second quartile, third quartile. So this is how we get that number of observation plus 1 divided by 4, number of observation plus 1 divided by 2, and 3 multiplied by number of observation plus 1 divided by 4. And that is not exactly the value, that is that 10th value, right? Is it that nth value in an ordered set? All right, so here the thing that to be noted is percentile split a variable into 100 equal parts, right? First quartile is nothing but 25th percentile, second is 50th percentile, and third is 75th percentile. And later if we talk about the IQR, that is nothing but interquartile range. So it is nothing but the range that computed only for the middle 50th of the data. So that is nothing but IQR IQR can be get from Q3 minus Q1. So that is nothing but our 5th percentile, right? Now, if we talk about coefficient of variance, so that is nothing but a relative measure to compare distribution with respect to their standard deviation, right? So the greater the number is, the greater the variability in the data irrespective of the scale. One more term we have is z-score. So as we have already discussed in our few project and in some videos, that for a given set, the z-score of a value is difference between a value and the mean of the set, right? That is divided by the standard deviation of the set, which is this. So a z-score from 0 means the value is the mean of the data, right? Depending on the size of z-score, that is positive or negative, we can say if the value is above or below the mean. So the magnitude of the z-score tells how far away the value is from the mean in terms of standard deviation, right? Next thing we have is the 5-number summary. So whenever we talk about this, the 5-number summary helps describe the center, spread and shape of data, right? So the 5 summary statistics are like minimum value will be there, interquartile range will be there, or we can say the quartiles will be there, or the quartiles, and the maximum value will be there. All right. So basically we get the 5-number summary just by describe function. So this will return all this value. All right. And another thing we have is the shape of data. So we can see that most of the time we have that we heard that the shape of data is skewed, or there is a skewness in our data. So what that basically mean is that extent to which the data value are not symmetric around the mean. All right. So where this could be left skewed, this could be right skewed. Okay, so where if mean is greater than median, then we can say positive or right skewed distribution. Where mean equals to median, then we say zero skewness or symmetrical distribution in their data. When mean is less than median, then we say negative or left skewed distribution in data. Next thing we have is the box plot, whereas it is nothing but a visual representation of all these 5-number summary that we got here. All right, so we just plot all these 5 numbers in that box plot. And if we talk about distribution of safe and box plot, so what happens, we have to determine the skewness of the data from its box plot, right? So the side of the bigger segment tells how the data is skewed, and if both segments are equal, then it is obviously the symmetric distribution as per the mean statement. And another thing we have is box plot to check the presence of outlier. So detecting the presence of outlier in data, the point on the rights are the outliers, so which we will definitely see in the example. And to note here, we have the presence of data points behind the whiskers, or we can say the fences, doesn't necessarily mean there are outliers, right? So the rule that box plot follows to decide what should be an outlier is that any point greater than q1 plus or we can say greater than third quartile plus 1.5 IQR, or less than first quartile minus 1.5 IQR is nothing but outlier. So if we talk about covariance and coefficient of correlation, so to measure how one variable varies with respect to the variance of another variable, we compute the covariance, right? So the metric only tells us to what extent two variables change together, and the metric cannot be the only evidence to conclude that variation in one variable is causing the variation in the other variable. Okay, so a positive value indicates that the two variable moves in the same direction, and a negative value indicates that the two variable moves in the positive direction to each other. Okay, so we can only determine the direction of the relationship between two variables, but to determine the strength of the relationship, we compute the correlation coefficient of two variables. So that is very important to get that. But to have something in mind that unlike covariance, correlation coefficient is independent of skill, right? And whereas correlation does not imply any causation. So this is very important that correlation does not imply causation. Now let's do some code, or we can say do some hands-on practice with that. So the data set is created for prediction of graduate admission from an Indian perspective. So we have GRE score, right? All the score of all those admission entrance level exam, right? We have GRE score, we have TOEFL score, we have university rating 1 of 5, we have statement of purpose, we have letter of recommendation strength, right? Undergraduate GPA, research experience, and chance of admit. All right, so let's load the libraries first, which will use NumPy, Panda, or of course Matplotlib. Then we need to import the data set, right? This is the data set admission predict, which I'll also provide in the description. All right, if we get the head of data, you can see that serial number is here, all the GRE score, TOEFL score, university rating, and so on so forth. All the columns are described. Okay, if we check the dimension of data, so let's see, this is how we can get that, just using data.shape, right, to get the dimension of data. Now it is telling that there are 400 observation where we have 9 rows or attribute, we can say, or column. So we have 400 observation, or we can say 400 rows, and 9 attributes, or we can say 9 columns. So this is nothing but 400 by 9. All right, where 400 is our number of observations and 9 is our attributes. Now if we check the information about the data and data type of each respective attribute, so what we'll use, we will use the info function. So to see the data type of each of the variable, right, number of value entered in each of the variables. So here you can see that these are our attributes name, this is our number of observations, and this is our whether it is null or non-null values, right? So let's do some EDA or exploratory data analysis with descriptive statistics. So let's get started with mean first. So how we will get the mean? Simply calling mean function. As we have our data, so data.mean function will return all the mean value for all the attributes, right? For serial number, GRE score, of course serial number, yeah, you can see that when we applied with data, so it has also given me for the serial number, because it will give for all data, right? And to ignore serial number, as it is not a continuous variable, we just ignore it, right? Now second we have is mode. So again, to get the mode is what we are getting is, if we want to get the mode of GRE score only, right? So we are accessing this GRE score from this data frame, and we are getting the mode with using mode function. So this will return me the mode. All right, so you can see that there are only two values with the same frequency. Okay, that is 0 and 1. All right, so third thing we have is median. Again, to call the median, we simply call a median function on the data, right? So which will print median value of the data. So here you can see that it has written all the median value for almost which looks like almost same for all the attributes. If we get the first quartile, or we can say the quartile 25th percentile, so how will we get that? Again, to get the data quartile 25th percentile, so data dot quantile, right, and we are passing q equals to 0.25. so 0.25 is nothing but 25th percentile of the data. So this is give me the quantile of all these values, right? If we get the second quantile, that is median. All right, so for to get the median or get the 50 percentile of the data, we will pass q equals to 0.50 in this quantile, right? So to calculate this median or the middle quantile, so it will return all the middle quantile values. Last but not the least, we have is 75th quantile, right? So again, to get this 75th quantile, we are passing q equals to 0.75. So it will return 75th quantile of all the data. Next thing, it is asking that plotting the summary, mean, mode, median using histogram. Okay, so to plot the histogram, first we are getting the value in each variable. For mean, we are getting mean value for GRE score. For median, we are getting median for GRE score. For mode, again we are getting the mode value. Okay, and we are printing that this is mean, this is median, and this is mode. You can check it out here. Second thing, we are trying to print that. All right, so as it has asked to print histogram, so we are defining the figure size 10 by 55. Okay, and in the histogram we are passing the GRE score. We are telling just print in 100 bins. Okay, and the color should be our light blue to plot that histogram. So here now we are giving the our lines, right? So how it will draw a line on plot for mean, median, and to mode we have given in GRE score. So here you can see that for mean this will get green line, for median this will get blue line, for mode 1 this will get red line, for mode 2 this will get red line again. As for mode value, we are getting two values for 0 and 1 here. Hope you remember this 0 and 1, and this is why we are getting two mode here as well for 0 and 1. So next thing, we are passing the X label and Y label to label it. So here you can see that how beautifully it printed our histogram. So here you can see that as it has described for mean, this is the green line. Okay, mean value. For median, mode 2, mode 1, and mode 2. Next thing, it is telling to check the data.describe function. So again, what it will do is it will return all the 5 summary of the data, right, along with some additional, that is count and mean. Okay, so here you can see that this output result provide the 5 number summary of the data. So this is nothing but we use from describe. Now to get the IQR value for TOEFL score, so again we know that the IQR value we get from 75th percentile minus 25th percentile. So that is nothing but Q3 minus Q1. So here you will get that IQR value. Now understanding the summary of statistic plotting box plot. So again, to work on the box plot, let us plot one box plot first for the TOEFL score, right, where return type is access and we are passing fixed size. So here you can see that we are passing third quartile labeled. All right, we are also passing median values for XY. We are passing first quartile for XY. We are passing min, max, IQR, and we are getting this value from here only. Okay, so here you can see that how nicely it plot the IQR or the box plot. So here this is max value, this is min value, this is third quartile, this is first quartile, and this is median. Hope you got it. Now we can observe from this graph that there is no extreme values, or we can say outlier in this case. So if there would be some outlier, they might be like here or here. Okay, so the data in this case was equally distributed. We can say that. You can see that the equality. Now if we talk about the IQR, as I said that it is nothing but Q3 minus Q1. So if we apply in all data, so here from data quantile Q3 minus data quantile Q1. So this will return the quartile, and the above output represent the IQR value of all the attribute. Okay, if we get the range, so again to get the range, we are taking the max values and we are subtracting this max value with the min value. So in this way we will get the range for all the data. So if we get the variance, so by applying data.var, it will return me the variance as I have described that how the variance will work. Okay, so to get the standard deviation, we just pass the std function with our data. All right, so it will return all the standard deviation of the data. Now it is telling to check the covariance and correlation. To first check the covariance, we normally use the COV function, that is cov, and with that print the covariance of each attribute against every other attribute. So here you can see that this is the covariance, right? serial number, with GRE score, with TOFL score. If we check covariance with SOP with CGPA, so here you can see take SOP from here and CGPA from here, so this will you will get the covariance for that. Now for correlation, we have a core function. All right, so to apply with our data, whatever our data frame. So again, if we check the SOP with CGPA for correlation, so here you can see that it will return me the correlation. Now it is asking a pair plot for checking the correlation. Import seaborn as seaborn, all right, to get the pair plot, and we are calling this a pair plot from this SNS library, passing the data. Kind is just reg, right? So that will basically plot for every pair of attribute and histogram along with diagonals. So this is what our complete pair plot is. All right. Next thing here, what it is describing, that here we can see TOEFL, GRE and CGPA score is highly correlated with the chance of admission. Okay, so if we get the let's say we are getting the GRE score, so this is here. So here we can say that this is highly correlated with the chance of submission. So here you can see that GRE score, and all of the attribute have good correlation with the chance of admission. Okay, so here you can see that majorly all of have good chance, and apart from the target variable, there is fair amount of correlation amongst the other variable. Now what we are checking is serial number. Okay, and we are telling that just drop it, because we do not need it anymore, so we have dropped it, and in place 2 that will delete it permanently or drop permanently. Now we are plotting heat map to checking the correlation, right? So mostly the correlation used with heat map. All right, so we are defining the fixed height. This is the heat map we are calling from SNS data.core, that is applying correlation heat map in heat map, and a note is true. All right, line width we have passed, FMT is here, C map that is magma. All right, so that is nothing but the color intensity that is based. And if we plot this, so you can see that this is for GRE, TOEFL, university renting, SOP, so there, so on so forth. And let's say if we again check with SOP with CGPA, so here you can see that this 0.72, right, with the heat map. And if we get it from SOP with the CGPA, 0.78, right? So here almost that rounded value. Now here check the skewness and kurtosis. All right, so if it is positive skewed, that is most frequent value are low and tail is toward high value. If it is negative skewed, most frequent value are high and tail is toward low values. So again that same thing, if mode is less than median is less than mean, then the distribution is positive skewed. If mode is greater than median, that is greater than mean, then the distribution is negative skewed. Histogram for checking the skewness. All right, so if we check the skew, so here we just call the data.skew function, and this is return the skewed value. So here you can see that it is, if it is negative skewed, so that means most frequent value are high and tail is toward low values. And if it is positive skewed, like this one, so that means most frequent values are low and tail is towards high values. Or we can say that in this case our mode is less than median, that is less than mean. Now to check the histogram for checking the skewness, so again we are getting our stats from scipy.stats and converting our pandas data frame object to numpy array, right? So that is we are getting GRE score and convert into the np.as array, sorted that as well. Now we are fitting that stats.norm with probability density function. All right, and we are passing the three values that we have here, and as the PDF requires, and we are telling that okay, now to plot these trees. Okay, so here we are plotting this by passing certain information to plot that. So here you can see that the blue line, that is our normal distribution with same mean, right, and the same variance, and this is the actual distribution. You can see that with the orange line. So we can see in the above graph that is negatively skewed, with skewed net score is minus 0.06. Okay, and also has negative kurtosis of k equals to minus 0.70. So this can be determined from this one. Now to conclude, we have done some amount of data exploration above, right? Nevertheless, we will be covering them more in detail, and how we use insight generated through data exploration to build machine learning models. All right. So thank you. Thanks all.